So we just explained a little bit in person of what we're going to be doing. So here's our video. Now we're actually going to go through this. So we have our live wall here that we use for demonstrations here at our training area in East Dundee. So Troy's going to go through now what we're going to do just to prove that this is all working in normal conditions. Is Troy's going to actually test this backflow, and then we're going to go through and show some of the pressure fluctuation occurrences that happen on here and how to remedy them. Okay, so go ahead, Troy.
Okay, so just to make sure that this is a working RPZ, we're going to test it real quick just to show you what our buffer is, what's acceptable. Put it on our low. We're going to let it bleed.
And he did bleed out his test cocks, by the way.
We did.
That was done earlier, but at the same time, we're just going to run through it.
Open up our high. We're going to let it bleed. And our number one check is holding at about 8, little over. Do a back pressure test on it. We're going to open our high, open our vent. Almost no discompression on this one, so the number 2 check is holding. Go ahead and shut that down.
I'm going to leave that on. Leave that on.
Leave that one on.
Yep. Do our screwdriver test real quick.
Do the screwdriver test. Make sure our number 2 valve is holding tight. Gauge did not drop at all, so that confirms that our number 2 valve is holding tight.
Always important, but very important in this condition to make sure that we don't have any kind of back pressure or anything feeding back on this valve that would be causing this thing to spit sporadically. So now we've ensured that that number 2 shutoff valve is closed tight. We don't have to worry about anything on that outlet side causing problems.
Okay, so what I'm going to do is reestablish my number 1 check. Bring it back to that 8. So we're holding good there. And now I'm going to flood the zone here and check what our relief opening point is. We're coming in at about a 3/8.
So is this RPZ working?
RPZ is working.
RPZ is working absolutely fine. All right, before Troy goes and shuts everything off, reestablish again real quick. So most of the time when we're trying to diagnose this pressure fluctuation where we're having issues, we're not lucky enough to have the gauge connected when we're actually seeing the pressure fluctuation. But we're going to do it here really quick so we can just see what's happening on our gauge. Now sometimes we can see this, sometimes it's the situation or what's causing it isn't going to be happening while you're there actually testing, which is unfortunately what seems to happen most of the time. Now, when we talk to people and they're having issues with this, we always recommend them having their test on the number 1 check assembly, test cocks open, and pressure on that gauge. Because that's the easiest way, if this is happening, to tell that there's fluctuation on this inlet side. So while this is on real quick, I'm going to recreate some of that pressure fluctuation here on this valve, and we'll see what happens on our test kit and on our pressure gauge here. And actually, Midwest, we've got our line pressure gauge down here on the bottom of that kit. So here we go. Oh, I've got to turn my valve on first. Now we can go. So I go slow, just a little bit of fluctuation, nothing happening. But we see our kit starting to move.
Starting to bounce around a little bit.
All right, so if we see that, the RPZ will withstand a little bit of that fluctuation. That's our buffer that comes into play there. Now, if that fluctuation starts getting a little bit worse, now we dumped out of our relief valve. Do it again. Go, and we're leaking again. We watch our test kit here. When we lose this inlet pressure, our gauge will drop. When that gauge drops to the point where the relief valve opens, the water is going to flow back through our relief valve. This is going to go back up to reset our zone. Do it one more time here. So we got a little bit of drip that time. Gauge went down, started dripping. Then our gauge naturally reset because our relief valve had opened when we induced flow through the backflow. One more time. Same thing. So that's how we can tell on our gauge if we're having that loss of pressure on that inlet side. Drop here, goes back up, and we get that spit out of the relief valve. Okay? So now Troy's gonna disconnect. We're gonna throw another pressure gauge on here real quick. Then we're gonna show you some of the things to try and remedy that fluctuation so your customer's not mad that this thing is leaking water all the time. Throw around, see if we have any leaks. Beautiful. All right.
Good.
All right, Troy, go ahead.
So now we determined that our pressure fluctuation is on the inlet side. And what we recommend is first determine the problem. We did see the pressure fluctuation coming from the inside. We got kids getting out of the classroom, flushing slowing valves. We got that huge drop in pressure. We know we need to do something on the inlet side to keep this from dumping all over.
So let's run it again really
We're
quick.
gonna run it again just to show you that it is still dumping, pressure fluctuation. A lot of dumping. The RPZ is doing exactly what it's supposed to do, but they don't want to see water on the floor. What can we do to fix this problem? What's going to prevent us from coming back and servicing this thing all the time? You know, replacing the number 1 check, number 2 check, just from getting beat up so much. So in line here, we have it bypassed where it goes directly through our RPZ. What we can do now is just send it through a soft-seated check, just by closing the inlet valve on this side and introducing the soft-seated check. Now, if you watch the pressure gauges from earlier, they were jumping all over the place. So just with a soft-seated check, it might slow it down a little bit. And sometimes it just does the trick with the size of the piping. Flip over that cushion, and in this case, it's actually working.
We'll run it a few more times here.
We'll run it a few more times, so you want to keep an eye on the gauges. Jumping a little bit. You're not getting the slamming.
Now we'll jam it on once.
Still a little bit of bouncing in the gauges, but we're not spitting anymore. You might not have that luxury of just having the number 1 or the soft-seated check working for you. So what we're going to do is add the expansion tank, and we actually put the line pressure of air pressure into this tank to make it work properly. So they come pre-filled due to hazmat and things like that. I think they only go into like maybe 30 psi. If you want to figure out what your incoming line pressure is and get kind of close with it to make this work properly, we're going to introduce the expansion tank.
And again, it goes upstream. We're going to go soft-seated check, then expansion tank, then the RPZ. This expansion tank is just maintaining that cushion in between here. So if that pressure fluctuation is massive, a lot bigger, this will help absorb the rest of it. All right, so we're going to run this again. Same condition. Doing it slow here. Not moving at all. Now we'll jam it on real fast like we did before.
Keep an eye on the gauges here.
Tiny little bit of bounce, but
no nuisance spitting, no dumping.
right? So we'll go back real quick. We'll shut everything back off, return it to its natural or its original state here, which means we're just running directly through to this. There's nothing upstream. So we've eliminated the soft-seated check. We've eliminated the expansion tank right now from the line. We're starting back over how it was when we arrived originally when this problem was occurring.
Gauges are all over the place.
And we can see that relief valve spinning, even when I go a little bit slower. We still get that leaking from that relief valve. All right, perfect.
Looks good.
We'll move on to our next one.
All right, so now we're looking at this Wilkins 375. We've determined by watching our pressure gauges that this is having pressure fluctuation on the outlet side of the RPZ. Whether it's going to be a pool fill, a chemical dispenser, soap dispenser, you get that quick hard shut off, and it's causing the RPZ to spit, doing its job, it's doing exactly what it's supposed to do, but the customer's calling saying, hey, occasionally there's water on the floor here. It might not be happening while you're at the facility, but you get there, hook up your pressure gauges, keep an eye on them, have things turn on and off to determine that the pressure fluctuations from the inlet or the outlet. So we have this one set up as the outlet. Basically, it's just the RPZ in line here. There's nothing after it, just the solenoid valve down here on our test stand. So Matt's gonna flip the solenoid valve, and you'll actually, if you watch these gauges, they're gonna jump all over the place. You're gonna get that nuisance spitting out of your relief. Little bit there. The gauges are all over the place here.
Now what the difference here is we can hear that audible thump, right? We can hear that water hammer coming back and hitting the backside of this check. So this is much easier to diagnose. That's why we're not going to test this one, is because usually it'll be a piping issue, something in the system, something that's been introduced, something that's new in the system. If it's just started happening on a backflow that's been installed for a long time. Also, commercial laundry machines are a big one as well, because their backflows are installed really close to those, and then there's a solenoid valve that's turning the water on and off to that machine, and when they slam shut, that backflow is going to leak, especially on the hot water side. Okay, continue on, Troy.
All right, so what we're going to do now is we're just going to introduce a soft-seated check down line, not the expansion tank quite yet, just to see what reaction we get with our gauges. So shut the top one off. Bottom one on. So now we have a soft-seated check back behind this gauge. Can't quite see it, but there is a soft-seated check on the outlet side of the RPZ.
Right. Remember when we had the soft-seated check on the inlet side, on the first one that we did, it helped. It stopped that relief valve from dripping. We told you there's some occurrences, but this does not work as well. This is one of them. So we'll run that again.
Keep an eye on the gauges.
Same condition here.
It is dripping out of the relief right now.
Trying to block my hand in there, but each time I'm just getting a couple of teaspoons of water out of that relief valve every time we shut that off. So when we used to tell people that a soft-seated check valve was your end-all be-all, not the case on this one.
Especially with a quick shut-off.
Right. One more time. And there we go, we still have that water.
So now we're going to introduce our expansion tank here. Once again, air it up to whatever your line pressure is at to make sure it's working properly. So now we're going to have the RPZ in line, our expansion tank, and then it's flowing through our soft-seated check. So it's going to trap that big cushion right here to prevent it from smacking that number 2 check. And we're going to see that a lot too. You're going to be out repairing this number 2 check quite a bit.
Mm-hmm. Absolutely. So we'll run that now. Nothing. I can run this all day long with this piping arrangement. I won't get any water out of this relief valve at all. Now, question we get asked a lot, and this might be answered in person while we're talking about this too. Because of how close this is to the solenoid valve, we do not need that soft-seated check valve in this condition. We could just do the expansion tank. Where this comes in handy is if we've got a super long run from where that shutoff valve is back to the RPZ. We want to try and have this area as short as possible, but that is trapping here between the expansion tank and that soft-seated check valve or solenoid valve. So if we took the soft-seated check valve out of this equation, the expansion tank would still be enough. But again, if you have a really long run, you need that soft-seated check valve to kind of reduce that amount of developed pipe there that this thing is getting hammered by. Okay?
We're going to shut this back off again.
Yep.
And put it into its original state. So now it's just the RPZ and the solenoid valve.
Right, back to how we started.
Spitting all over, gauges are all over the place.
All right. Perfect. That does it for that segment.